Hello, students. My name is Sonia Malik. I am your coding teacher and mentor. And in this lecture 14, you will be understanding function overloading as well as variable scope. Hello, students. In this lecture, we will be studying about function overloading. Yes, you heard it right. Function overloading, right? Okay, so to better make you understand about this function overloading, I would like to give you some generic example, like some real life example, so that you can get it better. So for that, let me take you to the open board. Okay. So I hope it is clearly visible. So let me select a pen. Okay, it's red. Okay. So suppose you are at airport. This is airport. Okay, this is airport. Okay. So you have to go from Delhi to Bangalore. Okay, so this is you, this is you, this is you, this is your mom, this is your mom, and he is holding some luggages in his hand, in her hand. And there is your dad. This is your mom. This is your he is your dad. Okay, he is your dad, and he is also holding some luggage in his hands, right? Okay, so what will happen now? What will happen? Like moms and dads generally have this thing. Your mom will come to you and say, "Hey son, please hold this luggage in your hand. I am very tired. I want my left hand, right hand to be freed, right?" So you will say, "Okay, mom, please give this luggage to me. I'll hold it." So you have holded this. Let me raise it off from the mother's hand, right? Okay, so you have holded this luggage, right? You have holded this luggage. Okay, fine, fine. Now your dad will come and say, "Hey son, please hold this luggage in your in your left hand, please. I'm very tired. I'm very tired. Please hold it." So your father will also give you some luggage to hold in the airport, right? Okay. Now your mother will again come to you and say, "Hey son, please hold this luggage. I am very tired." You will say, "Mama, where will I keep? My both hands are busy." Your mother will put this on your head. Hold it here. Okay. So she had put this luggage on your head. This luggage on your head. Okay. This luggage on your head. Now your dad will come and say, "Hey son, please hold this one more luggage from my hand in your hands." So you will somehow keep this luggage into your this hand where already one luggage was there. You have hold it, right? Okay. So can I say you become overloaded? Can I say you become overloaded? Like, can I say you become overloaded because you have holded so many luggages and baggages? So you are holding luggage 1, you're holding luggage 2, you're holding luggage 3, luggage 4, more than your capacity. So you're holding luggages, sorry, the spelling is wrong, luggages more than your capacity, right? So you're holding so many luggages, right? This is you at the airport. Okay, so way, let me take you back to the editor. Okay, so same way function is also overloaded. Let me write here. Function is also overloaded. Okay, like do you know like what is function overloading then? Okay, when, like in this example that I have given to you, what is the scenario? One boy, but too many luggages. Boy was only one, but luggages were multiple, right? Luggages were many. Yes. So luggages were too many, right? So function overloading means, the definition of function overloading is okay, multiple functions with the same name. Okay, so function overloading means multiple functions are there but with the same name. Okay, multiple functions are there but with the same name. Okay, these multiple functions are overloaded with different parameters, right? Okay, So function is just with one name, but they are overloaded with different parameters. Let me take you back to the drawing pad to show you something, right? Let us take the next page. So here you observe that one boy was there, but too many luggages. So in the function overloading, in the function overloading, you know, like what happens, there is a function name, suppose abc. This abc function will hold, suppose parameter number 1, parameter number 2, right? Parameter number 1, parameter number 2. Again you have created the same function, it is holding just one parameter. Again you have created the same function with same name, which is holding three parameters. I hope you are very much clear with the parameter term. Okay, the parameters are passed in the functions. Okay, so the function name is same. The function name is same. It is also ABC, but with different parameters. With different parameters. So this function ABC, this function ABC, let me write with another pen, is, this function ABC is said to be overloaded. To be overloaded. Why it is overloaded? Because this is just one function, the function name is same, abc, but it is overloaded with different parameters. Here it is carrying two parameter, here one, here 1 2 3. Okay, so what is function overloading? By now I hope the definition is clear. Same function but different parameters. Yes, same function but different parameters, or different types of parameters, right? Different parameters. So this is known as function overloading. Okay, this is known as function overloading. So let me take you back to the editor and do some operations, right? Okay. Okay, so let me write something here. Okay, wait. Yeah, so there can be two ways in which function overloading can be done. There are two ways in which function overloading can be done. There are two ways in which function overloading can be done. Okay, what are these two ways? What are these two ways? One is with the different number of parameters, different number different number of parameters, right? And another way is different data types of parameters, different data types of parameters, different data types of parameters. So let us implement this one by one. Okay, let us implement this one by one. It means function overloading can be performed in two ways. One where the parameter differs in number, like as you have seen in this example now, as you have seen in this example. Okay, wait, wait. So as you have seen in this example, the function name was same, but the number of parameters are different. Okay, okay, the number of parameters are different. Here there are two parameters. Here there is one parameter. Here there is three parameters. Okay, so this is one type of function overloading where the function name is same, but the parameters are different in number. Somewhere it is two parameters, one parameter, and three parameters, like right, like that. Okay, so let us implement this with different number of parameters. First part, different number of parameters. Let us implement this. Okay, okay, let me comment or erase it off. Let me erase it off. Okay, so how will you implement a function that is overloaded with different number of parameters? Okay, suppose suppose I have three variables. Int a is equal to 10. Suppose this is 10. Suppose I am having some another b variable which is 20. I know, like I am hoping that by now you're clear with this variable definition, declaration, initialization, right? Suppose I am having another with c, right? C is 30. Okay, okay. So suppose there is one function sum a b. This function will only sum a and b. Okay, another function, suppose I have sum a b c. I want three numbers to be added up. Which one? A b c, right? A b c. So let us implement these two functions above and see one by one what is happening, right? Okay, no, the function should, okay, the function name should be same. It should be sum only, right? It should be sum only, right? No sum abc and not sum ab. The function names should be same, right? Int b, I'm simply implementing, I know na, like I already told you, firstly the return type, then the function name, then open these round braces, and then inside write the parameters. What are these called? What are these called? Formal arguments. Yes, formal arguments. And what are these called? Where my cursor is there, line number 13. These are actual parameters. I told you no, this is the actual parameters, these are the formal arguments. Okay, so how will you add two numbers? A plus B, yes. This function added two numbers A plus B. Suppose there is another function with the same name. See, I'm repeating this again and again. With the same name. This is also sum. This is also sum, right? And here I am adding three numbers. Yes. Here I am adding three numbers. So what I'm doing? What am I doing? A plus B plus C. Yes. Okay. So the function name is same. It is also sum. It is also sum. But the number, the amount of parameters given are different. How? How they are different? Here only two parameters are passed. Two parameters are passed, right? And here three parameters are passed. Three parameters are passed, right? This is how they differ in number. This is the first type of function overloading. Clear? Okay, now you will think how, if the function name is same, how it will be getting identified. The compiler will automatically identify it. When the compiler execute this line number 15 now, he will see, okay, the function name is sum, then it will go and search this sum function and find, okay, this is some function, and it then the compiler will see that, okay, two functions are there with the same name, but it will see that there are two arguments I have to search, two arguments, so it will take that function which are having two parameters passed. Okay, two parameters passed. So although the compiler will see that this is also name sum, this is also the function name sum, but it will see that only two parameters I have to find, so it will not take this, because compiler will see, okay, the function name is same, that is sum, but three arguments are passed, but I have to find for two. Similarly, for this function, for this sum function, line number 16, compiler will search for some function to execute, and he will see I have to find a function named sum with three parameters. So when compiler will see line number 4, he will see, okay, the function name I am searching is same, I am searching for sum, and this function name is also sum. Then he will see the parameter, oh, two parameters, but I have to search for three. I have to search for three parameters. So it will not take this function. Then compiler will move to line number 7 and see, oh, this is the same function name that I'm searching for. I'm also searching for some function name, and it is also a sum name. But I have to find the parameters 3. Then he will count, okay, 1 parameter, 2 parameter, 3 parameter. Compiler will make sure that the sum name, the function name and the parameter should match, and it is matching, and it is matching. So compiler will execute this function, right? Shall we print this? Shall we print this? Let me put an endl to differentiate between these two sums. Let me write a print statement also. The sum generated by two numbers, so that we can identify easily that this is the sum that is given by only two numbers, A and B. And let me print some another line. It makes your code more readable when you are writing these printed statements. Na, it gets a, like, the reader will get a clarity, okay, this is the sum which is generated by three numbers, right? It is always a good habit to provide a clue to the reader of your program, right? Okay, so let me run this code. Let me run this code and see what will happen, right? What will happen? Oh, cool. The sum generated by two numbers is 30. The sum generated by three numbers is 60. Yes, it is clear. It is sure. because the two numbers were 10 and 20. That's why the sum came 10 plus 20, that is 30. So this function gave you 30 and this function gave you 60, because 10 plus 20 is 30 and 30 plus 30 is 60, right? I hope this is clear. I hope this is clear. This is the first type of function overloading, where the function name is similar, function name was similar, but the number of parameters differ. Okay, this is the first type. This is the first type. Correct? Okay. Let me erase it off. Let me erase it off and let us proceed to the second type. Let us proceed to the second type. Okay. Second type was same function name, same function name, but with different data types of parameters, but with different data types of parameters, right? Same function name but with different data types of parameters. Let me take you to the open board to explain this fact to you, right? Okay, let me take you to the open board. This is my open board. Let me take a fresh page to explain you. Okay, pay attention, pay attention. This is again a function ABC. Okay, it is taking int a comma int b. It is taking two parameters. Okay, it is taking two parameters. Return type is int, right? So these are the curly braces and some code will be written here, you know very well. Okay, then there is another function with the same name ABC, but this is taking different data types of parameters. That is double of a comma double of b, double of b, right? And the return type is double, and their curly braces, some computation is going on. This is known as function overloading with different data types, data types, data types of parameters, parameters, right? Let me highlight it. Function overloading with different data types of parameters. This is another type. So what you observed here in this function, what you observed? The parameter, the number of parameter are same. Here also two parameter, parameter number one, parameter number two. Here also two parameter, parameter number one, parameter number two. But what is the difference? The data type of parameters. Yes, there is int data type. There is int data type. There is a double data type. This is the twist. This is the twist. Here is a double data type. The data type differs. Okay, if some other function is made like abc char of a character of b, then this is also the same function with same name of abc, but the data type of parameter differs because it is char. Okay, but for now let us take only example of two to avoid any kind of confusion, right? Okay, okay, so I raised it up. Okay, see, the function number name is same abc, but the data types is different. This is another type of function overloading. Why again I'm saying function overloading? Because the same function is holding two different types of parameters, right? Okay, like in the example, one boy was there and he was holding so many luggages. Here the function is one, it is just one. Yeah, it is initialized two times, but the name is one, abc and abc, and it is holding different kind of parameters. It means different luggages, right, and baggages, right? Okay, so this is a second, this is a second type. This is the second type. Second type. Let us move to the editor to implement this function. Let us move to the editor. Okay, we have already moved. So how will you implement? Tell me quickly. Let us take two variables. A is equal to 10. B is equal to 20. Let us take two double numbers. Double of A is equal to 4.5. Let us say. Double of B is equal to 5.6. Okay, so first function is sum function. Function name will be same, sum, pass a comma b. So you have to take different variable names. Say, take a c and d. Take c and d. Okay, take c and d, because otherwise it will be matched a b. Okay, okay, sum c comma d. right? Okay, so here you passed a comma b, here you passed c comma d, right? Let us implement these two functions above. Int void, because we are printing, not returning, right? That's why void. Sum int a comma int b, curly braces, c out. Like, why I have not taken int? I explained you with the example of int and double return type, but here I am just printing because my concern is to show you function overloading, not the return typing. That's why, right? I am making it simple for you guys. Another is void sum double of c comma double of d. Okay, double of d. So out c plus d, right? Let us run it off and see what answer we will get. Ooh, we are getting something like 30 and 10.1. Let us put a endl to see the different answer. It is coming in one line, and no, it is not appearing that much readable, right? Oh, it is giving us 30. It is giving us 10.1. Why? Because 10 plus 20 is 30. See, 10 plus 20 is giving you 30, and 4.5 plus 5.6 is giving you 10.1, right? That's why the answer is like this. That's why the answer is like this. So this is a second type where the function name was same. That is sum. The function name was same, but the data types of parameters differ. Here, first is int, second is double. Second is double, right? Second is double. Okay. I am hoping that by now you're clear with the concept of function overloading and its two types. Okay, now I already explained you about function overloading, right? Let us see one more concept. Similar concept. No worries, right? No worries. Okay. Let me take this only. Let me raise it off this. Okay. Fine. Okay. Okay. So let me call two functions and let us see something, right? Suppose I am implementing same function name with same parameters and same data type. I am writing a same function name. Earlier I was okay. Let me take you to the open board to explain you something, right? Then you will be very much clear in this. Okay. Let me take some fresh page. Right? Okay. So I was explaining you that some functions are made which were having same name. This is also ABC. This is also ABC, but they are differentiating in number of parameters. Either their parameters are 1 2, there are 1 2 3. So although the function name was same, but they differ in number of parameters. This is the first type I explained you. Second was let me use some other color. Second was this function name was same. Again, the function name was same, but they were different in data types. Here I am using int de, here I am using double de. Suppose double de. Okay, double. Okay, so these are the two types that I already explained you. Like, the function name was same, but number of parameters are different. This is the first type. And the function name is same, but they are differing in data types. This is the second type I have explained you. Any doubt up to here? This is a second type I've explained you. So I am giving you a situation. I am very uh like, I want to test you on something that I have explained you, right? So I am taking your test. So I want you to take a situation on you. If the function name is also same, number of parameters are also same, of two functions, but no but and data type dt is also same. What will you do in this situation? Can you guess, like, what answer you will get? Nothing is different. This is function name is same, function parameters, number of parameters are also same. Here also two parameter, here also two parameter. Data type is also same. Here is also int, and here is also int. Now what answer you will get? Either you will get a error, or you will get a proper answer. Can you guess, like, can you guess on this situation where everything is same? Everything is same of these two functions. No differentiation is there. How compiler will behave in this situation? According to me, it should give some error. It should give some error. Let us see what error it will give. If it will give some error, what error it will give, and why it is giving that error. Why it is giving that error. Okay, I know my handwriting is not very good at the editor, at the open board, but still. Okay, main purpose is to explain you the concept, right? Okay, let us move to the editor and see what error will it give if everything is same, right? Everything is same. Okay, so I'm making this function c out a plus b, and it is also same function. Nothing is changed, not a single dot is changed, right? Int, okay, C out A plus B. C out A plus B. Let us see what will happen. Let us see what will happen. Let us run it off and see what will happen. Ooh! See the error box. See the error box. The cursor. The cursor where this is there. It is saying redefinition of void sum int comma int. See. In line number this where I'm highlighting it. Where I'm highlighting it. Down bottom. It is saying redefinition of void sum int comma int, and it is also saying void sum int comma int previously defined here. It means it is saying you have duplicated these. This void sum is already defined above from line number 4 to line number 6, and you are again defining it. This is wrong. Like here it is behaving the same way it behaves in concept of variables. If I do na this thing, int a is equal to 10, and again I do int a is equal to 20, like it will also say, like we have already studied this in previous lectures. It will say that a is previously defined. For variable also it is saying that a is previously defined, and for function it is behaving the same way. It means it is not allowing function to get duplicated, right? So what happens is, let me show you. Let me move you to the open board and show you like what happened. So I was telling you that it will give some error. So what error it is giving? It is giving ABC. Suppose this is also ABC. Everything is same. Two arguments. Everything is same. Two arguments. Data type is same. DT data type. DT data type. Everything is same. It is giving error. ABC is previously defined. DEFINED here, right? ABC, it means it is already declared in here. Why you're declaring it again and again with same everything? It is not acceptable. You're making one thing duplicated two times. What is the need? To do so? Okay, so it is giving this error. Like in terms of, like if I am writing int a is equal to 10, in terms of variable also it is giving the same issue. It is saying if this a variable, let me take some other highlighter. If this a variable is already defined with data type int, why you're defining here? Right? If this has declared with some other data type, na, it will not give error. Why? Because the data type is different. At least one thing is different. There is some USP. In businesses, we use this term, na, USP. Unique selling proposition, something like that. Like what is the USP in your business? Why it is not the same with every other businesses? So the businessman used to give some USP. Like our business is different from that because. So this the same way there should be some USP. So there in these two statements, in these statements, the USP is the data type. Although it is also a, but it is double A, it is int A. That is the differentiation. Okay, that is the differentiation. Okay, but otherwise it will give you error. Let me take you to the editor. It will give you error. Okay, so can we do something else? Okay, Okay, so it is giving you error. Nothing can be happen. Nothing can happen. But if you use some other function name, suppose you are using summing. Suppose you're using summing function, then it will not give you error. Why? Because the function name is changed. Now they have become two functions, not just one. Yeah, it is duplicacy. I wrote two times int A, int B to explain you, right? So I raised it. Now it is giving 30 30, which is correct. Which is correct. Because it is also doing 10 plus 20, it is also doing 10 plus 20, right? So from this you have learned two things. Either the function name should be different, although the function arguments can be same, or if the function name is same, then argument should be different. Then argument should be different. Okay, so what you have learned from this example, quickly tell me. If the function name is different, if the function name is different, parameters can be same. Parameters can be same. It means there is some differentiation factor. Two functions should not look same. There should be some differentiation either in the function name or in the parameters, right? If the function name is different, then parameters can be same. Okay, if the function name is same, the parameters should be different. Parameters should be different. Different in what terms? In terms of quantity. In terms of quantity, I hope you're clear with this quantity term. Quantity means one function is having two parameters, other is having three parameters. Okay, so in terms of quantity they can be different. Why it is not giving a? Okay, in terms of quantity, in terms of data types, data types of those parameters. This is the same thing I've explained you above. This 2 points I have only cleared you above, right? If the function name is same, either differentiate them in terms of parameters, either differentiate them in terms of data types of parameters, right? I hope that this thing is clear to you. This thing is clear to you. Okay, so the function overloading is covered. The function overloading is covered. Let me take you to some other topic, other interesting topic. Let me take you to some other interesting topic. Shall we proceed? Are you excited? Okay. Let us proceed to the other topic, which is known as scope. Scope, or popularly for this coding specific, we can say variable scope. We can say variable scope. Let me write it. Okay, scope or variable scope. Variable scope. Okay. Okay. So let me take you to the whiteboard to explain you about what is scope, how many types of scopes are there in C++ language, right? Let me use some white pen. Okay. It will give more clarity, right? Okay, what I'm writing, right? Okay. Scope. SCOPE. I'll try to draw nice at my best, right? This is scope. This is scope. Okay. You know, like what is scope? The region where a thing is considered valid. The region, it can be any region where a particular thing is considered as valid. Valid. Okay, it is the scope means outside that boundary, the thing should be considered invalid. Within that boundary, something is considered something. I'm not exactly sure like what thing. Like it cannot be specific for one or two things. It is for everybody, everything like that. I'll give you some good example, right? But scope is a region inside which this is inside. Suppose this is a scope. This is scope. This is something A. Okay, this is something. Suppose this is passport. So inside this region, this is considered valid. But outside this, this is outside. Outside this, it is invalid. Invalid. I means invalid. Invalid. Because the scope of A, because the scope of A was up to this boundary where my yellow line is there. It is up to this boundary. So if within this boundary this is valid, this particular A thing, I am not sure like what is A, I'm just giving example. I'll give you a real time example, no worries. But I'm saying there is a some product A. Inside this scope it is valid, but outside it is not applicable. It is not applicable anywhere, right? This is the scope of this A. The region where it is considered as valid, right? Let me clear it up. Let me take a fresh page. Okay. So what I was explaining you, I was explaining you about scope. Okay. So suppose you are a person, which you are, obviously. Your name is Varun. Your name is Varun. And you are a citizen of India. Yes. Okay. So you are a citizen of India and your name is Varun. If you will go to South Africa, if you will go to South Africa, your name will the same. Your name will only be Varun. South African people will call you Varun because your name is Varun. Its scope is global. Its scope is global. Name scope is always global. Wherever you go to Asia, you go to Canada, wherever you go, your name will be Varun only. Your name will be Varun only, right? Your name will be Varun only. So scope of this Varun is global, in the entire world, like world, global. The scope is planet, world. Okay, it is global, it is valid in the entire world, wherever you go, in whichever country you go, right? The scope is global. Okay. Okay, let us take another example whose scope is local. Local means it is not valid outside your country, but it is valid inside your country. Okay, this is local, suppose. Okay, let us take some fresh page. Okay, so I think the global thing is clear. Global means your name is valid everywhere, in every country you go. Canada people will call you Hey Varun, right? Because your name is Varun only, right? Okay. Second scope is local. Local. Okay. Suppose this is your country India. This is your country India. This is the boundary of India. Suppose this is the boundary of India, right? Okay. Suppose you have done, I'm taking some rough example. Okay, so don't take it very seriously. This is just an example. Okay, so this is India. This is some score. This is boundary of India. Okay. Okay, so suppose you have done some degree. I'm not saying exactly what degree, but you have achieved some degree studying in India. Studying in India, you have achieved some MBA or MTech, whatever it is. I'm not exactly sure like about the particular degree, but some degree you have achieved here. Okay, like it is happening na. In some countries, this degree is not valid. In some other countries, suppose you go to Australia, this degree is not considered valid, and in Australia, the professor will say that you have to attain this degree from scratch. You have to study in Australia to get this degree again. Okay. Okay, this degree is not valid. This degree is not valid. Okay, so this is scope is local. It means its scope is local. It is within the country only, but outside the country it is not valid. Outside the country it is not valid. Within India this degree was valid. Okay, everybody thinks that okay, you done MBBS MBA, but outside country this is not valid. This is not considered valid. They will say that you have to do this MBA or MBBS again from scratch. And some another example if I'll give you. Okay, suppose there is currency. You know, no, like when foreign people will come to India, then they have to convert their money in rupees. It means the scope of dollars in outside country, in foreign countries. But when some people will come to India, then dollars have to be converted into rupees. Okay, because these dollars are having their scope within the country, but outside the country it is to be converted. Okay, I this is called as local scope, where the scope of these dollars are within country, within Canada, like that, within something. The degree is valid only in India, not in Australia, something like that, right? Right. So similarly, okay, similarly, variables are also having some scope. Variables are also having some scope. Some, oh my bad, my handwriting. Let me write it again. Sorry for the disruptions. I'm not having that much practice writing. Okay. Similarly, read this line carefully. This is very important line. Variables are also having some scope. Variables are also having some scope. Okay, variables are also having scope. What scope they are having? What scope they are having? Global as well as local. So this variable is having two scope: global scope, local scope. Let us see what this local and global scope are there, and then we will move to the editor to perform some operations, right? Let me explain you on this editor. Suppose this is your main function. Okay, we used to write this thing again and again on editor. Now I am writing here. Suppose this is your main function. This is some return 0, right? Every time I used to write like this: int a is equal to 10, int b is equal to 20. Okay, you know, like every time I used to write here. Let me move to the desktop and show. Like every time what I used to write inside this main function something like that: int a is equal to 10, int b is equal to 20. Every time I used to write something like that. Okay, it means I am locally defining these variables. Yes, I am locally defining these variables. Okay, this is the local variables. Local variables. Because its scope is local. You know what do you mean by local? Like I explained you, a degree is applicable or valid within the country. So it is applicable within a function. The variables that you define within a function are known as your local variables. The variables that you write inside some function are known as your local variables. This is your main function and you are defining and initializing these variables here. It means they are local variables because their scope is local. Why? Because they are defined inside a main function. But if I define this, let me take you to the open board. If I define these variables A and B outside the main function or outside any other function, suppose I erase them from here, and I define these A and B outside any function, not inside but outside any function, these variables become your global variables. Okay, students, these variables become your global variables. Why? Because they are not inside a function. They are not inside a function. They are outside this main function. They lie outside this main function. How do we write it in the code? In the editor, how do we write it? Can you explain? Okay, it is int a is equal to 10, int b is equal to 20. This is how you declare the global variable outside the main function. Why they are known as global variables? Because their scope is outside the main function. Okay, so their scope is outside the main function, right? Okay, I hope that this thing is clear to you. Okay, fine. So, okay. Okay. So the next thing is that I would like to tell you. The next thing is I would like to tell you. Okay. Let me take you to the whiteboard. Let me take you to the open board. Okay. Now, let me take a fresh page. Okay. I hope you're clear with this fact, like what is a scope and what are global and local scope variables, like that. Okay. Suppose this is a function. Suppose this is the main function. Suppose this is the main function and I am declaring some int a is equal to 10. Int a is equal to 10, right? I am writing something as int a is equal to 10. Again, I am writing int a is equal to 20. Let me use some other pen so that you can be very clearly knowing it up, right? Let me erase it off and take some other pen. Yellow. Yellow. Again, I am writing int a is equal to 20. You know, like what error it will give? Can you guys tell? I explained you this 1,000 times. Although this is a joke, not 1,000 times I have interacted with you, but I'm just giving example that I have explained you so many times when I used to code and explain things up. So can you guys tell like what error it will give? It will give A is already declared. A is already declared. Why you are declaring it again? If A is already declared int A and int A, why you're redefining it? Why you are redefining A? This error it will give, right? I told you na just 5 minutes ago, when you're writing same code and they're saying why you are redefining when it is already declared. But this will not happen. This will not happen if you erase this A, if you erase this A, if you erase this A and write it outside and write it here int a is equal to 10. Now it will not give you error. Although what I did, I erased this int a from here and write it above. Now it will not give error. Although it is same, although it is declared twice, int a is equal to 10, int a is equal to 20. This is declared twice, int a, but still it does not give an error which is called redefinition. It does not say a is declared twice. Why you duplicated this a? Here you have also written int a, here you are also writing int a. It will not give you error. Why? Because there, let me write with some other pen. Their scopes are different. Their scopes are different. Okay, I'm also skip speaking and writing so that if my writing is not very much clear, then you can get an idea or a clue by my voice, right? Okay, so their scopes are different. This is a global scope because it is declared outside this main function. This is a global and this is a local, 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 right? So their scopes are different. That's why they are not considered defined as duplicately twice. Okay, let us move to the editor and see if this technique works or not. Let us move to the editor. Okay, let me show you something. Don't worry. Okay, return 0. Yeah. Okay. So here, suppose I'm writing int a is equal to 10, int a is equal to 20. First, see like what error will you get? What error you will get? See carefully. Let me run it off. Ooh, see, it is saying redeclaration of int a. Int a is previously declared here because we did it 2 times. Okay, but if I erase it, copy it from here and paste it as a global variable on the top, it will not give you error. Although it is same, although you are defining it 2 times, you are duplicating it, but still it will not give any error. Why? Because the scope are different. See, no error will be given. The program is executed. We have not printed anything. That's why it was empty, the output box. But okay. So it is not giving error. Why? Because the scopes are different. Here the scope is global. Here the scope is local. That's why it is not saying that you have declared 2 times. Because you have not declared 2 times in the same scope. Scopes are different. Scopes are different. Scopes are different. Suppose I'm doing something like this. Let me see like what error it will give. This is also global scope and I'm declaring this a 2 times in same scope. Let me see like what error it will give. Oh, it is saying redefinition of int a. Int a is previously declared here. By this thing, now I am understanding two things. I am understanding two things. Let me take you to the whiteboard and explain. I'm getting two things from here, right? Suppose this is your main function. See carefully, I'm explaining very good, right? This is your local scope. This is your local scope. Outside this main function is your global scope. This is your global scope, right? This is your local scope. Fine. Okay, see carefully. See, I will be explaining very next level, right? Okay. If you are declaring two times same variable here, int a is equal to 10, int a is equal to 20. This will give you error. What error? Redefinition error. It will say, what it will say? It will say you have redeclared it. It will say error. Okay, it will give you error, definitely. Redeclaration error. That you have declared this A, redeclared this A two times. Here also, here also. This will give you error. Suppose, if I am declaring these both in the, okay, again I'm writing. This is local scope, right? So I have written two int a in the same scope. Suppose I am writing these two in the same scope above, again in the global scope. Same, int a is equal to 10, int a is equal to 10 and int a is equal to 20. This is also giving us error. Why? Because we have redeclared it in the same scope. This is the global scope and we are declaring it two times. Okay, it is giving us error. But let me raise it off. Okay, let me raise it off. Okay, this is your global scope. So one time if I'm writing something here, I'm declaring a here, another time I'm writing here, it is not giving us error. Why? Because these two declarations are in the different scope. Here it is in the global scope, here it is in the local scope. That's why it will not give us any error, because although the declaration is same, but they are in different scopes. As simple as that. ASAT, as simple as that. Smiley, right? Okay, fine. Okay, so we have also seen the implementation. Okay, so what next? So this is the last topic for now. One small thing is left in this topic, and then this topic will be ended, right? The function overloading and the scope of variables, right? The last question is, let me take you to the open board. The last question is, this is your main function, return 0, right? I am writing int a is equal to 10 and one outside declaration int a is equal to 100. Okay, so one time I declared this a in the global scope, one time I declared this a in the local scope. Okay, global scope means not necessarily outside this main function only, outside any function is your global scope, out inside any function is your local scope, not just it is very specific to this main, right? Okay, now my I want to print this a, I want to print this value of a by doing a cout left shift a semicolon. Can you guys guess what will be the value of a? This is a blank box and I want you to think like what will come in this box. Let me highlight it. This box, this red box, can you say like what value will be printed on the output? As an output, what will be here? Question mark. What is the actual value of a? Here it is 10, here it is 100 and I'm printing it. Global scope will prevail, win, or local scope will? Who will win from these two? The value which is of A, which is defined globally, that is 100, or the value of A which is defined locally, that is 10. What will be the value of A that will be printed? Can you guys tell? When the same variable name is declared with different value, that is 100, same variable is also declared locally and same is declared globally. Always, let me write with some other pen. Always local variable wins. Local variable wins, right? So here the value of A is 100, that is globally. Here the value of A is 10, that is locally. Who will win? What will be the value of n printing? This will be 10, because the local variable will win. The local variable will win, right? This is the rule. This is the rule. But let me erase some part, because it has become very messy. It has become very messy, right? Okay, let me erase entire thing. Okay, let me erase it entirely, right? Okay. So what I explained you just now, what I have explained you now, suppose there is some declaration outside that is 100. Oh, I this time I did 1000. No worries, no worries. This is global. Okay, this is also a declaration. This is 10. This is local. This is local. If I'll print this C out A, what will be getting printed? 10, because I already told you local will get privilege. This will prevail. This will win over local, over global. Sorry, right? So who will win? Local value will win. Okay, this local will win. It means 10 will be printed. But I'm very biased here. I'm very biased here. I'm doing a biasness. I want this global to get printed and not local. By default, like automatically, this local will be getting printed. Okay, because it will win over global variable. But I want this value of global variable should get printed. This 1000, not this 10. So what I'll do, I'll change something in the printing statement. In this cout statement, I'll change something. What I will change? Can you guys tell what I will change? In earlier, what I was doing, cout A. This is how I was printing things, right? This is how I was printing. Cout left shift A. But now I want this 1000 to get printed, this global. I will use scope resolution operator. See, I have made some changes. You will see, like, okay, by mistake the cursor has pointed here and put these 4 dots. But now, no, it is intentionally done by me, okay? This is known as scope resolution operator. This is known as scope resolution operator. I will not do simply cout A, but I will do cout scope resolution 4 dots A. This will print 1000 and not 10. It means the global value is prevailing. This is intentional. By default, the local value will get printed. But if I want global, then put a scope resolution. Scope resolution symbol is this 4 dots. Okay. Let me highlight it. These 4 dots, where I'm drawing a red boundary, these 4 dots before the variable name A. Let us run this code off and see if it is actually doing so. Suppose I'm writing int is equal to 1000 above. Let us take the same example explained on the whiteboard. Int is equal to 10. Let me print this cout A. Let me print this value. Let us see who will get printed. See, 10 is getting printed. Okay, because its scope is local. Let me write it here. Local I have written. Its scope is global. But if I'm getting bias, if I'm doing some bhedbhav, and I want this 1000 to get printed, so what I'll do, I'll put a, see carefully, line number 8. I'm putting scope resolution operator. See where my cursor is there. See my cursor. Two scope resolution two pair of dots are printed. So let us run it off and see if 1000 is getting printed or not. See, 1000 is getting printed. See, 1000 is getting printed, right? It means biased nature of mine. I printed globally, intentionally, right? So this is the last topic for today. This is the last topic for today. So let me summarize what I've explained. Let me take you to the open board and summarize what we have done. Okay. So let us see what let us summarize what we have done. Summary. This is summary or summarize, right? So what we did? Firstly, we studied function overloading. Function overloading with two things. With what two things? Different parameters. Parameters. Different data types of parameters, right? Data types of parameters, right? Okay. Second thing that we studied is scope or variable scope. Variable scope. One was global, one was local, and last thing we covered is if there will be a fight on printing these two, who will win? Who will win? Okay, so by default, this local will win, but on by if we want to print this global, we have to use scope resolution operators, SRP, SRO, scope resolution operator, right? So this was a video all about. So this is the video all about. I wish you all the very best for this video. Get through it, understand it, practice some questions, some tricks, practice some questions on your own based on this topic. Try performing function overloading on your own, and all the best, all the very best. Thank you for uh, being with me till the lecture. Okay, thank you, students. Thank you. Have a nice day. Bye bye.